Hello friends, welcome back to our channel Abhi Chemistry Tutorial. So in this video we are going to learn about DARZEN'S reaction. So we are going to study this on the basis of CSIR NET examination, which is going to be conducted in September of 2022. So for that we are preparing, and the first thing I have posted is Stobbe's condensation, naming reactions from organic chemistry. So the first video I have posted is Stobbe's condensation. If you have not checked that video, kindly go and check it in the description box and also in the playlist. And many people are watching without subscribing to our channel, so kindly subscribe to our channel before going to the video and kindly recommend to all your friends. So now let's get started. DARZEN'S reaction. It is a type of aldol condensation. Okay, so we know what is aldol condensation. Two aldehydes or an aldehyde and ketone will be condensed to form a product called aldol. So that is called aldol condensation. And here we are using a haloester and a carbonyl compound. So the carbonyl compound may be aldehyde or it may be a ketone. We are combining this with an alpha haloester. So in the presence of a base. So who has the major role here? The base. So which base can be used in DARZEN'S reaction? Either sodamide can be used or sodium alkoxide can be used. Okay. So the product we get is the epoxy ester. So it is also known as glycidic ester. Since we get glycidic ester as the product, we call DARZEN'S reaction as DARZEN'S glycidic ester synthesis. So for example, consider this reaction. So we have taken a ketone, acetophenone, and also a compound, chloroethyl acetate. So this is the simplest ester, no? So it is an alpha halo ester. See, this is the functional group and this position will be the alpha carbon, and to this the chlorine is attached. So alpha halo ester, the major condition for DARZEN'S reaction is it should have an alpha halo ester. And in the presence of base like sodamide or sodium alkoxide, so here I have written sodium ethoxide. Either sodamide or sodium alkoxide can be used. So see the byproduct, an epoxy ester. So you know this oxygen bonded to two carbon. In a cyclic form it is called epoxy group. And we have an ester here. So it is called epoxy ester. The other name for epoxy ester is glycidic ester. And the byproducts we get are ammonia and NaCl. So the next step is that we will go into the mechanism. The mechanism of DARZEN'S reaction is taken into three steps. So the first step is the abstraction of proton from the ester. So we have two components as reactants, an ester and a carbonyl compound. So we take the ester at first and the base. So see, here you can see sodamide, Na plus and NH2 minus. So this NH2 minus, the base, abstracts the proton from this alpha carbon. So this is functional group alpha carbon. So from this alpha carbon, one hydrogen is taken by NH2 to form ammonia, NH3. And this carbon is left out with a minus charge. Here you can see CH, Cl, one hydrogen is gone, so minus charge, COO, C2H5. So this is a carbanion. Yes, it's a carbanion. So what is an anion? It is a nucleophile in general, right? Nucleus loving group, that is it should have a negative charge. So carbanion is a nucleophile and this nucleophile adds to the carbonyl group we have taken. So that is the second step. Carbanion acts as the nucleophile and the reaction, that is the step 2, is nucleophilic addition of this carbanion to the ketone or the aldehyde, whatever we have taken. So here you can see, here we have a ketone in general. Already we have taken acetophenone as the example and here I have given it in general in case of acetone, in case of a ketone. So in case of a ketone, this bond is shifted to this oxygen to give a negative charge over this oxygen and the carbon will be left with the positive charge. And this carbanion has a negative charge and this negative charge goes and bonds with this carbon and this oxygen is left out with the negative charge, which we call it as oxyanion. So the product of the second step is oxyanion. So here you can see RRC, O minus and CHCl COO C2H5 as the same. The last step is the halide ion is removed and the formation of epoxy ester by SN2 reaction. Okay, so through SN2 reaction, this chlorine is removed and this oxygen minus is bonded to this CH, so that an epoxy ring is formed and we get the final product, that is glyceric or epoxy ester, and the chlorine ion is left out. So next we are going to discuss what we can do or what we can get from the glycidic ester. So usually we know from esters, on hydrolysis we get an alcohol and an acid. Similarly, with this epoxy ester, when we are subjecting it to alkaline hydrolysis, we get ethyl alcohol, it separates here, and we get ethyl alcohol and an epoxy acid, that is glycidic acid. So what we can do with this glycidic acid? This glycidic acid can be further warmed with an acid. You know, decarboxylation occurs. But in this case, after decarboxylation, rearrangement also happens. For example, if this CO2 is removed, we have two hydrogen. And here you can see this product. One hydrogen is shifted to this carbon and this bond is shifted to this carbon to form double bond O. And what is the final product? It is an aldehyde. So the DARZEN'S reaction can be used to get a glycidic ester, and from that what we can gain or what we can get as the product is an aldehyde, a modified aldehyde. So this is all about DARZEN'S reaction, and I hope the video is useful for you. So hit the like button if you like the video, and also share to all your friends and family members. And don't forget to subscribe to our channel, and the next video we are going to upload is acyl condensation. So continuously we are going to learn all the naming reactions in organic chemistry, so that you will be getting good idea for the competitive exams like CSIR NET exams. So see you all in the next video. Until then, bye. Thank you. Take care.